Good morning. As was mentioned earlier, I'm Craig Ford. I'm a propagation research scientist at Scion. I was tasked early on this year with looking at mini plug technologies and automation of mini plugs, and a bit of a literature survey and whatnot. And my first attempt at this talk was a very detailed review of everything, which by the end of it, everybody asked me, yes, but what is a mini plug actually? So I've revised my talk now, so hopefully it makes a lot more sense. Yes. Helps if I'd figured out how to click this thing. Okay, that works. So, I better start with what is a mini plug and why am I talking about it. And the key thing to highlight here is that what we're talking about in terms of mini plugs is quite different to what we're used to seeing in forestry. So typically a forestry standard is to use a container size of about 60 to 500 mils, depending on that's a volume measure, depending on what species you're producing and over what time period. And the example I've given here is a very common forestry tray, TS48 from Transplant Systems, which has 125 mil volume, and you can fit about 430 of those trees per square meter. So fairly efficient compared to some of the bigger containers, and these containers will go directly into field for field establishment and planting. Some plants that require a slightly longer growing period might have a slightly bigger plug. What we're talking about when we're talking about mini plugs, however, is something a whole lot smaller. And you can see the scale difference here. Mini plugs are usually between 10 and 33 milliliters in volume. And the example I'm showing here is also from a Transplant Systems. It's a TS256 with a 16 mil cavity, and there you can fit about 1,600 of them per square meter, which I'll get into a little bit more about the advantages of that in a minute. But what I would like to point out is that these little guys are transplants. They're not something that's going to go directly into field. You can imagine it'll be pretty difficult to establish that under field conditions. But having that transplant has a lot of advantages to it. And what we can see is that it has applicability, and I'll chat a bit more about that later, across crop types. And Jana mentioned earlier about microplugs, which is actually where we derive plants from tissue culture in these small mini plugs. But also there's the application for seedlings, which this happens to be, a radiata seedling, and also cuttings. So carrying on with what is a mini plug, well, there's also a few different types of mini plug we can use. And at the moment at the Scion Nursery, we have a demo crop busy growing in these mini plugs, radiata, where we've used a loose media fill, and there you can see an example of it. And generally that you're using a fixed container with a mix of your own description growing media, which could be peat-based, coir, pine bark, perlite, pumice, or even vermiculite. And whoa, that was quick. Holy smokes. Okay, so that's the one type. You can also get ones which are preformed, holding it together, so you don't have to wait for a root plug column to consolidate that before you can move it around. And some examples of those are the Jiffy pots and paper binding with Elipot. And then we also have preformed plugs with a binding agent, which is often called a glue plug. And you can see here's an example of some of those glue plugs with some tissue culture plants in them. So, why mini plugs? So the first and probably most important reason, and it really speaks to this efficiency in terms of number of plants per square meter, is that when you have an enclosed growing environment, you really have good control over the growing conditions. And you can see this example here where you can control things like light intensity, humidity, temperature, and you can start growing these a lot earlier than what you might otherwise. So for example, at Scion Nursery, we're about to start sowing in our open ground seedlings, whereas that crop I showed you earlier, we actually sowed that 2 months ago. So we had a 2-month head start. And this really underlines it. So I've got a couple of relevant references at the bottom here, but in essence, what I've just said here about the importance of this environment is highlighted here by the first 5 weeks of growth and development is really critical in forestry species and allows you to optimize growing, optimize germination, and ultimately gives you a nice homogeneous crop. So everything comes up at about the same time. The second part that we found from the literature especially is that, in fact, using this transplant system, and the Americans will call it a plug plus one or transplant plus one, or there are various names for it, but what especially the American research has shown is that because we've taken those successfully germinated, we've been able to sort and count them, what we find is out in the field we have really nice uniformity and survival, and actually at the end of the day we have larger and better quality plants, and you can see here both in field growth measurements where there's a 60 to 80% improved growth after 5 years, and also this feeling amongst foresters that in fact this method has led to significantly larger and better plants. So there's opportunity there for us to have a look at that as well. I'm not going to go too much detail about this third one, but what Jana was speaking about earlier, where we are producing large numbers of embryos of various varietals, that's hugely advantageous in terms of getting out large numbers, but how do we get them out to field? We need some way of doing that, and a mini plug, in this case we call it a micro plug because these are tissue culture plants, provides a very good way of doing that. So these plants can then be planted directly into field, either open bare root type facilities or containerized. So the fourth opportunity, and the one really I think is the main context of this study, was looking at the opportunities for mechanization and automation, where really we want to be mass planting high-value plants. And at the moment, really, the tissue culture-derived plants, we have an intermediate step at the moment of going to cuttings, using mother stock hedges, producing cuttings. And here you can see our nursery team at Scion busy establishing some of those cuttings, a really manual task, and with labor restrictions and labor shortages getting increasingly difficult. And so we want to try and improve the working conditions and address some of those issues. So through mechanization, and here you can see 2 examples of mechanization that you can use to do those transplants out in the field. This one happens to be one based in the US at the moment. This one is based in Australia, both of which, this one in fact has been modified to be an 8-row. Both are applicable for the kind of densities we'd need for pine establishment in New Zealand. And then of course there's also widely used in the horticultural industry transplant machines for container to container transplant. But what is important is that these mini plugs have really well consolidated plugs and therefore can be easily extracted and transplanted mechanically. The other advantage, of course, if you have a central laboratory or somewhere that's producing these things, because they're at such high densities, it's quite easy to transfer those to and between nurseries. So I have a very quick video to show an example of one of these transplanters working in Europe, which I'll have to ask for the assistance from behind. So there are examples. There are also examples available where this sort of handling is done automatically. You stack it on and it automatically transfers those plants and plants them out, so that even that step is potentially unnecessary. But you can imagine the advantage of this is being established at the same time as somebody else is sowing their seed and still needs to germinate. Cool, that's great. If we can kill that. I have 2 more slides, I think, genuinely. So, mini plug history and New Zealand future. this is where I started with my last version, and I think that's a good place for me to end here. And really to show the history of this. This is not a new thing in the industry. The Americans started this in the mid-70s. They tested it and across a number of species in the 80s and 90s, and by the late 1990s it was pretty commercially used. Weyerhaeuser is a company that uses it extensively and have done it across the board in a number of species. More recently in Europe, there's been some of this work on further species. And in fact, even in New Zealand, we've actually looked at this mini plug transplant system, although I can't see much published on it. So there's still scope for us in New Zealand. My final slide is that, is it applicable in a New Zealand context? Well, what I've said here is that having been grown specifically for transplanting and being widely used in bear roots across the USA for several years and across multiple species, there's no reason to think it wouldn't be successful here. And certainly for us, it offers an opportunity to be able to assist with the clonal, the varietal deployment that we see from tissue culture and even from cuttings. Thank you.